What is model distillation? Model distillation is simply teaching a smaller model to think the way a bigger expert does. Imagine a huge professor model that's read everything and a lighter student learning directly from the professor's answers instead of studying the entire library. The teacher doesn't just give the final answer, it shares hints about how confident each possibility is, like hearing the reasoning behind the choice. A strong interview answer is, distillation transfers the behavior of a large LLM into a smaller one, using the teacher's predictions as soft guidance. This works because it shows you understand both the process and the purpose. Another helpful picture is turning a giant textbook into clear, exam-ready notes you can carry anywhere. This is exactly why distillation powers mobile apps, cars, and edge devices. If this feels new, that's okay. It becomes natural as soon as you see how much intelligence the student can retain. How distillation works? Distillation begins with a large teacher model that already understands the data deeply. Instead of giving the student strict right or wrong labels, the teacher shares softened probability signals that reveal its reasoning. Think of watching a skilled guitarist, noticing not just the notes, but the pressure, the timing, the flow. These soft signals help the student learn patterns the raw data can't show. A strong interview line is, soft labels carry richer structure than one-hot outputs, allowing the student to learn the teacher's behavior. This phrasing works because it highlights the value beyond accuracy. Picture it like a chef explaining why each spice matters rather than just handing you a finished dish. Interviewers may also ask why soft labels matter, and the simple follow-up is, they expose nuance. Don't worry if this feels abstract. Once you see the student mirror the teacher with far fewer parameters, it clicks instantly. Why distillation helps compression? Traditional compression can feel like shrinking a photo by deleting pixels or lowering its quality. It becomes smaller, but you often lose detail. Distillation avoids this because the student learns the tutor's way of thinking, rather than losing structure. A strong interview answer is, distillation preserves the teacher's behavior while achieving 10 to 100 times reduction in size and significant speed gains. This lands well because it shows you understand both efficiency and fidelity. Imagine fitting the same wardrobe into a carry-on suitcase by folding smarter instead of throwing clothes away. That's what companies do when they deploy LLMs on phones or cars. A common follow-up question is, why not only quantize? The simple reply is, quantization changes precision, while distillation preserves reasoning. These ideas feel complex at first, but with a little practice, the difference between structural compression and behavioral transfer becomes second nature. Follow-up questions you'll face. One question you'll almost always get is about temperature. The simple way to say it is, temperature softens the teacher's probabilities, so the student sees more than a rigid yes or no. Higher temperature smooths the distribution, like brightening a dim photo to reveal subtle shapes. Another popular question is whether you can distill without original data. Yes, you can use synthetic or unlabeled data and let the teacher produce predictions. Interviewers like this answer because it shows you understand privacy-sensitive scenarios. They may also ask about trade-offs. The key point is that training becomes slower, but deployment becomes dramatically faster and cheaper. DistilBERT is the classic example. Smaller, quicker, and still strong. If they ask when distillation might be a bad idea, The safe reply is when the teacher itself is unstable or poorly calibrated. Don't worry. These follow-ups become intuitive as you practice. Production ML workflow. A typical production workflow begins by collecting data, then training a strong teacher model that captures the full complexity of the task. Once the expert exists, we distill its knowledge into a smaller student. Think of mastering a topic deeply before teaching someone the streamlined version they'll use every day. After distillation, the student is deployed in environments where speed, memory, or battery matter. Mobile apps, vehicles, robotics, and other edge systems. Monitoring then keeps everything healthy, catching drift early, just like apps receiving updates when patterns change. A strong interview phrase is, distillation bridges research-grade models and production constraints by keeping intelligence high while keeping compute low. This works because it shows awareness of both engineering and business needs. With this mindset, the whole workflow starts to feel logical and predictable. You'll get comfortable with it quickly as you build real systems. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.